Lihat ya, makin pinter.
Iya.
Kenapa sih?
Dapat.
Pulang balik udah lebih. Pulang balik udah sekali.
Jam berapa sih?
2:30.
Udah jalan berarti.
Udah lari lagi jadi.
Saya nggak bisa aneh.
TPS nggak pernah pakai.
Nggak pakai.
Beli dong.
Kan lu pakai Windows.
Gue nanti nyari.
Sekarang 1
Iya,
giga.
hostingnya.
Oh hosting.
1 gigaan. Kemarin gue ngecek nyari yang 2 giga memorinya 400 ribuan sebulan.
Okay.
Itu sih.
My name is Gilang. Okay, I've introduced myself earlier.
Cuma dapat 15. Sekarang udah
Satu aja ya.
19 tahun.
I'm here will introduce you about Haystack and ElasticSearch. Okay, first of all, I had warning. This is this presentation really related to Django framework. Okay, this is framework. Okay, it's about me, and we could skip this because I have introduced myself earlier. Okay, now. What is Haystack? Haystack is like a modular search for Django. It's in Django there is a concept of pluggable apps. So we can plug an apps from third party, including our Django application. So. And Haystack is de facto application for search. So if you are familiar with Django and you have developed search in Django, you must heard about Haystack earlier. Okay. So what actually it do? Haystack basically let you write your search code once and choose the search engine you want it to run on. So it's kind of a layer on top of other search engine. So you could just write the code once, and okay, we could look at the search engine it's for. So we have Store, ElasticSearch, Boost, and Zapier. What the most interesting part is sometimes for our web application, it is a simple application. It doesn't need a really high-end search engine. So for that type of application, we can use the simple search engine, which is Boost. Boost is basically a Python project, Python project. So now when you build web application in Django, you just want a simple search. I mean, your web application doesn't have high traffic like that. So why bother build a giant search engine? You could get away with Boost. It's simple. You just need pip install Boost, then everything will be done. Zapier here, it's a C++, Solar, it's Java, ElasticSearch is also Java. Okay, how do you implement Haystack in your Django application? It's simple. First step, you just need pip install Django Haystack, and it will install Haystack in your environment. then you configure your setting, Django setting application. You just need to say you install this Haystack in your Django application, and you define a Haystack connection. This is the engine you want to use. Maybe you want to use WUS or Zapier and other. The concept is interesting because when you build a web application, such as maybe you are in a hurry and you want search function, you could just use WUS, and when your application getting bigger and you have higher traffic to your web application, you can switch the search engine, the back-end search engine, without rewriting any of your code. So that is the nice concept of Haystack. Okay, the step 3. This is how you define index. What do you want to index from your Django model, your application? Step 4, you create a template. This is you define what field you want to include in your full text search. And step 5, you install search engine. Most of the search engine is really easy to install, and the easiest was WUS. Azure and Elastic were Java and Lucene based. So when Azure and Elastic, you need to install Java in your web server. That is why for a simple application, it's too overkill. Okay, step 6, you index your database, your model, and that's it. Okay. Here's some advanced use of Haystack. With this simple addition, Haystack already gives you a bonus feature, something like highlighting, like when you search in your full text search, your result, you could highlight your result. Let's say you search for word street, and the word street in your text will be highlighted. Autocomplete, you could build an autocomplete. Of course, you could build autocomplete from your database, but here it's faster. In the both, and the other advantage is when you search from your database, there is no scoring. When you search for, let's say, street, it will give you all the result which contain street, word street, and there is no such as like waiting and wait search, like scoring like that. So basically, it will just give you the result. And here, both the advantage of both is you could define some criteria, which is let's say when a report in your database contains some value, the scoring, the weight of scoring is higher, so it will be come up in your search result in top of your result. So it's not equal, and you could boast some of the criteria based on a field, or let's say updated status, like I want this street record, but from earlier updated status, something like that. And rich content extraction, if I'm not wrong, you could extract data from a document such as PDF or and etc. And maybe other document file. Okay. The most interesting part is spatial search. Okay. I always like the spatial search from Haystack, but we will discuss it later on. Okay. Here I want to add more about the ElasticSearch. It's one of the search engine that Haystack support. So when you get higher traffic, you could switch to either two, Solr and ElasticSearch. Basically, ElasticSearch is almost the same with Solr because it's based on the same engine. It's based on Lucene. So Solr is based on Lucene and Elastic is also based on Lucene. But what interesting is the ElasticSearch were created by because of the developer want a search engine that really scalable. So ElasticSearch were built with scalability in mind. Okay, I know now Solr add that some kind of feature for scalability, but it add later. But in ElasticSearch, it has a scalability from the first concept. It's distributed real-time search and analytic engine for the cloud. That's the tagline of ElasticSearch. This is all the feature that overview that ElasticSearch have. You could have distributed. The concept is in ElasticSearch, it's called node, one node or two nodes. So when you have a higher load, you could just add another node of another node to your network, and it will balance itself. It will recognize the new node, and it will sharing the data, and it also where is it? High availability. In high availability, just say you have 15 nodes, and one of your node is broken, failed. So the other will recover for it, and the other node will cover all the search part. It's also support document oriented. For this part, it's almost like MongoDB with a minimal feature. And you could get a RESTful API. You could connect to ElasticSearch in RESTful. Like you could just CRL like delete node or delete your index, and then you could query in a RESTful way. It's Apache to open source license will on top Apache Lucene. Okay, this is all the feature that ElasticSearch. Okay, this is the most interesting for me. Okay, the spatial search. It's from Haystack. Okay, Haystack gives you interesting feature spatial search, but this spatial search only available if you use backend search engine Solr and ElasticSearch. So if you use Whoosh or Zapier, you cannot use spatial search. Okay. As we know, spatial search, you could use spatial search from your database. If you're familiar with the database concept, if you want to use spatial, you only have actually one option: PostgreSQL. You could use MySQL, but it's last time it's immature and it's not complete feature. And you mostly almost all the company, if you want to use spatial, you use Postgres. But actually, if you use PostgreSQL with spatial component, it's for some application it's overkill. You have to include the key support and all the component from the PostgreSQL. You need to install another package for it. So what's interesting about Haystack and spatial search, you could use spatial search only including field longitude and latitude in your database. So you could use MySQL. You just need field longitude and latitude in float. So and Haystack will give you spatial search without you install the database support for spatial search. So this is the option you have within distance, ordered by distance, and polygon. The polygon part is only spatial to only available for ElasticSearch. So Solar doesn't have a polygon search. So the query within, you could query your record based on the square box. Like you have 2 points, it left top and bottom right coordinate, and the Haystack will give you all the record with a longitude, latitude within that square, within that box. Okay. The within, it's for radius search. Radius search. Let's say you want all place. You want restaurant in 10 kilometers from where I am now. This is the within count. The distance is basically when you use the within, it doesn't give you how far the place from where you are. If you use distance, the query itself will calculate how far you from the result. Like say that restaurant is 2 kilometers from me here. Okay, and this is the order by distance. You can order by distance. So basically, order by distance. Like say, I want to order this the closest from me. Mostly, the application use it like that. Right? So you want to show to your user the restaurant the closest from where he are. And the polygon is like a within, but it's not box, but it's a polygon. You will use it as polygon. You give several points, and it will give you all the result in that polygon. Okay. This is the example. If you want to search place within 10 kilometer radius and order by distance, okay, you just need 2 points, longitude and latitude, and this is how we query with Haystack. And you define the within location and radius 10 kilometer and show the distance from the location and order by distance. Okay, it's that simple. You don't need to configure your database. You just need longitude information and latitude information in, like set a float field, the float in your database. Okay, I think for reading, you could go to ElasticSearch and ElasticSearch, especially for ElasticSearch, because ElasticSearch is really a huge application, and it contains many powerful queries. the query itself is more powerful than SQL. If you want to search something, it's more powerful than SQL. They call it a search DSL. It's more complex and it gives you more result and it's faster. At some point, there's some company that doing 21 billion record in 900 milliseconds. That fast. Okay, I think, thank you, that's all from me. Okay, any question? Okay.
Sekarang kan kita saat ini sedang memilih mana untuk apa research query kan. Nah, kalau misalkan yang mana di antara semua itu yang bisa support fuzzy search dari paling mudah?
Fuzzy search. Fuzzy. Yang paling mudah sih pasti bus ya. Untuk kayak untuk skala kecil pasti paling mudah pakai bus. Fuzzy sepertinya saya tidak tahu kalau apakah bus bisa mendukung fuzzy, tapi kalau ElasticSearch you could configure it to support fuzzy search. Or you could configure to build an autocomplete, and I think it could be built to support fuzzy.
Oh, different module.
Yeah.
Different module.
No, different configuration. You have to tweak the configuration.
Which one?
ElasticSearch. I think you
Yeah, next position.
ada pertanyaan lain? No more question?
Does it do facet search as well? Faceted search?
Yeah, it is equally facet search. It has support from Haystack, and if you want to use more powerful facet search, you could go with the ElasticSearch tweak configuration itself. You have to tweak more, but if you are simple faceting, yeah, you could go with the Haystack. Okay, no more question.
For scoring from the Haystack, it doesn't include the advanced for scoring, right? Only boost.
Yeah,
But if I'm from the provider and the backend, like ElasticSearch, it already has the scoring.
yeah. I think from the Haystack you could define some way scoring to some point. Yeah, you could maybe if you have simple weighting scoring criteria, you could go with the Haystack from the Haystack search index module. I think the index is like I think yeah, you could define the here in search index in your model, but if you have a really complex scoring, you need to go with the configuration in the search engine itself. Okay, more questions? Okay, thank you.